All right, this morning we are going to be talking about something that is new, but not really new. The topic we're going to be looking at is direct variation. And what this amounts to is taking something that you already know about and just kind of renaming some of the parts of that. So here's what you need to know. A direct variation is a y equals mx plus b equation, which we have done a lot of work with. So it's a y equals mx plus b equation with the b equal to 0. So right there is the important fact. We're going to call a y equals mx plus b equation a direct variation if it has b equal to 0. Now, you know, what we know is that with y equals mx plus b, the m in that equation is the slope, and the b in that equation is the y-intercept. Okay, so what we're saying in this direct variation definition is that the y-intercept is going to be 0, which means that the line will always cross the y-axis at 0. So a direct variation is a y equals mx plus b equation. The b in that equation has to be 0, which means that the y-intercept is 0, which means that the line will always cross the y-axis at 0. This last fact down here is one of the most important things you can know about a direct variation because it makes recognizing them pretty easy. Now, one last thing we need to talk about here that's going to change is that when an equation is a direct variation, they are going to rename the slope just a little bit. You know that m is the slope, but in a direct variation, they're going to call that slope the constant of variation. So if you see them talking about the constant of variation, that is really just the slope of the line. So, now what I want to do is show you how to use this definition to do the problems that you're going to be doing today. All right, the first kind of problem they're going to give you is a problem where you have an equation like y equals negative 2/5 x. And what they're going to do is ask you, is it a direct variation? So is it a direct variation? Well, here's how you're going to decide. Is it a direct variation means, is it a y equals mx plus b equation? Okay, and does b equal 0? So those are the two things you need to look for. So first of all, on this one, is it a y equals mx plus b equation? Yes. And does the b equal 0? Well, in this equation, we know that the m is a negative 2/5, and then it's plus nothing right here, so yes, that b is 0. So this is a y equals mx plus b equation. The b in that equation is 0, so I'm going to say yes, this is a direct variation. Now the instructions are going to say if the answer is yes, then what is the constant of variation? Now, as I said before, when they ask you that question, what is the constant of variation, that really just means what is the slope. So this was a yes answer, so I have to identify the constant of variation. My slope is a negative 2 over 5. So you're going to be asked two questions. Is it a direct variation? To determine that, you need to look and see, is it y equals mx plus b, and does b equal 0? And then if it's a yes, you're going to give the constant of variation, which is just the slope. All right, so here's another one. Let's do y equals negative 2x plus 1. All right, so I'm going to look at this. Is this y equals mx plus b? Yeah, y equals negative 2x plus 1 looks just like y equals mx plus b. So this is a yes. Okay, so then I have to see, is b equal to 0? Well, in this equation, my m is negative 2, and my b is positive 1. So the answer to this question, is b equal to 0, is no. So this one is not a direct variation. It doesn't have that characteristic of having b equal to 0. So I don't need to worry about a constant of variation because it doesn't have one. All right, negative 2y is equal to negative 6x. All right, so when I look at this equation and I'm trying to decide, is it a direct variation, the first thing I need to know is it a y equals mx plus b? And the answer is no, it's not. But you know what we've learned is when they aren't y equals mx plus b, we can fix them. So I'm going to draw my line right down through that equal sign, and I want you to think about how we fix it. We want the y to be alone, so we want this y right here to be alone. So what that means is to get y alone, I have to cancel out this negative 2. Well, how am I going to cancel that out? I know that negative 2y means negative 2 times y, so this is multiplication. So I can divide by negative 2 to cancel that out, and I'll do that on both sides. So these negative 2's will divide out, and I'll get y equals negative 6 divided by negative 2 will make this 3x. So is this a y equals mx plus b? Well, it wasn't. But now it is because I fixed it. So is b equal to 0? Well, when I look at this equation, I have y equals 3x, so now I know my m is 3. And then I don't see a number here at the end, so that does mean b is 0, so this would be a yes. So this is a direct variation. So they're going to want me to give the constant of variation, which is the slope, and that slope would be 3. So when they give you your equation, if it isn't y equals mx plus b, you'll fix it so that it is. All right, so let's look at one more of these. Let's say we have x plus 3y is equal to 15. And just for the sake of helping myself out here, I'm going to make that 1x plus 3y is equal to 15. So the first thing I want to know is this a direct variation? Well, is it a y equals mx plus b? No, it's not, but I can fix it. So to fix it, I want to get y by itself. So first I come over here to this 1x term, and I'm going to subtract 1x to cancel it out. 1x minus 1x is 0, so that cancels that out. So now I have 3y is equal to a negative 1x plus 15. And remember, on this side, we want to arrange it so that it's mx plus b. Now, to get y by itself, I have 3 times y, so I will divide everything by 3. And when I simplify, I get y equals a negative 1/3 x plus 5. So is that a y equals mx plus b equation? Well, it is now. I fixed it. So if it's not y equals mx plus b, you fix it. And then my second question should be, is the b equal to 0? And the answer is no. So on this one, it is not a direct variation. So no need to identify the constant of variation. So to kind of recap on these problems, when they give you an equation and they ask, is it a direct variation, you need to consider two things. Is it y equals mx plus b? And if it's not, then it's simple, you fix it. And then once you have it fixed, is the b equal to 0? Because that's what every direct variation has to have. It has to have b equal to 0. Alright, so now, the next kind of problem they're going to give you is a graph. And they're going to ask you the same questions. Is it a direct variation? And what is the constant of variation if it is? So in this problem, here's what we have to remember. When they ask me if this is a direct variation, I have to remember that b is equal to 0, which means that this line has to go through the origin. So is b equal to 0? Does the line go through the origin? And yes, it does. So I would say yes, this is a direct variation. So on a graph, that's the test. Does it go through the origin? Okay, so because it is a direct variation, they're going to want me to give them the constant of variation. And to get the constant of variation, what I have to get is the slope. So this is where I will go back to my old friend, rise over run. Now to do slope, remember we need 2 dots. There are 3 dots on this line, so you just need to pick 2 of those. I'm going to use these 2 that I've marked in red. I'm going to start over here on the right. And remember, rise goes up or down, so to get to that other point, I would have to go down the grid. And I'm going down 1, 2, 3, 4, which will make the rise a -4, since I went down 4. And then I am going to run to the right. And I'm going to the right 1, 2, 3, 4, 5. So that would be a positive 5. So I get my slope is -4 over 5. That will not simplify. So my constant of variation, my slope, would be -4/5. But I want to emphasize again that this one is a direct variation because of that point right there, because it goes through the origin. That's what you're looking for. All right, so take a look at this graph. Would this be a direct variation? Well, the origin is right here, and I want you to notice that that line doesn't go through the origin. So, no, this is not a direct variation. Not a direct variation because it doesn't go through the origin. So I don't need to do the constant of variation on this one. All right, and then we got one more. Would the line that you see here be a direct variation? Well, I'm going to look and see if it goes through 0, 0, goes through the origin, and it does. So the answer on this one would be yes. This is a direct variation. And because it is, they're going to want me to identify the constant of variation or the slope. So to do that, I'll need 2 points. So I think I'll use this point and this one. So we're going to rise over run. So starting from here, we will go up 1, 2, 3. So that'll be a positive 3. And then we are going to go to the right 1. So that'll be a positive 1. So 3 over 1 is 3. And my constant of variation would be 3. So, taking you back to the beginning. One more. A direct variation has to be y equals mx plus b. So if it's not, you fix it so that it is. And this is the important part. Once you change it to y equals mx plus b, that b has to be 0. And because b is 0, that line will always cross the y-axis at 0. So it'll always go through that origin point, 0, 0. Any questions about this lesson, be sure and contact me and let me know.